Hey everyone, welcome back to my YouTube channel, The Creative Chemist. My name is Afolashade Emmanuel, your chemistry tutor. I want to say thank you to everyone who has subscribed to my YouTube channel, and for everyone new on this channel, please like, share and subscribe to my YouTube channel. Thank you. In today's tutorial, we shall be learning the topic oxidizing and reducing agents. In the last video, I explained what oxidation is and what reduction is, and today we'll look at which of the substance is the oxidizing agent and which of the substance is the reducing agent. So come along with me and let's dive into it. Oxidizing agents. Now we have the reaction CuO plus H2 to give Cu plus H2O. We have learned what oxidation is and what reduction is. I beg your pardon. What oxidation is and what reduction is. Now, what is oxidizing agent? In every redox reaction, there is always movement of electrons from one substance to another substance. In every redox reaction, electrons will move from one substance to another substance. So a substance can cause oxidation while the other will cause reduction. So for us to define oxidizing agents and reducing agents, we define it based on what that substance causes. So if there's causing oxidation, we will be calling it a term. If it is causing reduction, it has its own term. Now, what is oxidizing agent? Oxidizing agent is a substance that causes another substance to oxidize. Oxidizing agent is the substance, oxidizing agent is a substance that causes oxidation. It causes another substance to be oxidized. And when it causes another substance to be oxidized, itself is reduced. While reducing agent is an agent that causes another substance to be reduced. So that means that when it causes the reduction, itself is oxidized. So let's look at this together. I said oxidizing agent causes another substance to be oxidized. For example, the CuO plus H2 to give Cu plus H2O will learn oxidation, and I'll just recap. Oxidation is addition of oxygen. Oxidation is also removal of hydrogen, and oxidation is also the loss of electron. Now look at this. CuO to Cu, H2O. So what happens to CuO? CuO became Cu. There was a removal of oxygen. Oxygen was removed from CuO, and the removal of oxygen is called reduction, while the addition of oxygen is called oxidation. So for us to identify our oxidizing agent and our reducing agent, it is going to be in the reactant side. It's not going to be in the product side. So you get your oxidizing agent and your reducing agent from the reactant side. So CuO, Cu, reduction. That means CuO has been reduced. So it is the one that caused the oxidation, that allowed H2 to receive the O. So CuO is reduced, reduction. So our oxidizing agent is CuO. It is the one that is reduced and allow oxidation to take place. Now H2. H2 is the one that is oxidized, and it is the one that allowed reduction because it was one that accepted the oxygen from CuO. So H2 is our reducing agent. So a recap: oxidizing agent is an agent that causes another substance to be oxidized, and itself it is reduced. Reducing agent is a substance that causes another substance to be reduced, and itself is oxidized. So that's the definition for reducing agent and oxidizing agent. I hope you got that. Please get examples and learn more. Look at them. You would always get the oxidizing and reducing agent from the reactant side. So get examples and look at it. Identify the oxidizing agent and the reducing agent. So one paramount thing is you must be able to understand oxidation and reduction. Okay, so from here we'll be going to oxidation number. Oxidation number is a very paramount tool chemists uses to track oxidation and reduction, especially in an equation whereby you cannot really identify if it is a redox reaction, if there is oxidation or reduction in that substance. So we use oxidation number to track it. Now, what is the oxidation number? Oxidation number is the imaginary charge an atom carries in a compound. The imaginary charge an atom carries in a compound, assuming all the electrons are completely transferred. So if I have Na2O, so the oxidation number of sodium is the imaginary charge sodium is carrying, sodium has in this compound, assuming all electrons has been completely transferred. So we want to learn how to get the oxidation number of each element in a compound of each atom. Okay, so let me still use my Na2O. What's the oxidation number of Na? For us to calculate the oxidation number, I'll quickly highlight some rules you will need to follow. The first rule is that the free atoms, the free elements, the oxidation number is 0. When you have Na, the oxidation number is 0. It is free, it's uncombined. Potassium, K, the oxidation number is 0. I have K, oxidation number is 0. Na, standing on its own, free element, the oxidation number is 0. Now for our ions, the oxidation number is the charge on that ion. So if I have K plus, the oxidation number of K is +1. I have Cl minus, the oxidation number is -1. Now when you have a compound, the sum of the oxidation number of that compound is equal to 0. So Na2O, that's sodium oxide, the oxidation number is equal to 0. So we'll look at some examples and we'll find the oxidation number of either each element or one of the elements in that substance. So let us look at K2Cr2O7, and we are looking for the oxidation number of Cr in K2Cr2O7. I said that the oxidation number of a compound, the sum of the oxidation number of a compound is equal to 0. So that means the oxidation number of this compound is equal to 0. And I'm looking for Cr, chromium, in potassium hepta dichromate 6. Now, so let's split it down. I have 2 potassium plus 2 chromium plus 7 oxygen. So your O, I'm writing it bigger so that you can know it's oxygen and not O, equals to 0. Okay, so what's the valency of potassium? Potassium has atomic number 19. So that will be 2,8,8,1. So 1 will be the valency. So that is going to be a +1 plus 2 chromium, that is what we are looking for, plus 7 oxygen, atomic number 8, which is 2,6, and then it's going to be -2. please, you can follow me on my other videos. I have explained how to find the valency. Okay, so that's 2 times plus 1, that's plus 2 chromium minus 14 equals to 0. So mathematically 2R will be 14 minus 2, 2Cr will be 12, Cr will be 12 over 2, which is equals to plus 6. So the imaginary charge on chromium in K2Cl2O7 is plus 6. So this is how to find the oxidation number. So I have laid the basis for balancing of redox reaction, which will be my next video. So please learn what in the last video. Please assimilate what oxidation and reduction is. In this video, learn what oxidizing and reducing agent is and how to find oxidation number, so that when we get to balancing of chemical redox reactions, you will be able to find it easy. Thank you so much for watching this video. Please like, share and subscribe so you would always get notified when I post a new video. Bye.